Right then, folks, we're on to box 37. There we go. So this should be straightforward. It should be a working set. It's here for optimisation, and he wants it to work on, because it's an 80 channel set, he wants it to work on all 80 channels centralised for that, so it'll be tuned up either on UK channel 1 or CPT channel 40 to achieve that. We always prefer to do sets as 40 channels because they work better, but this customer wants this doing as 80 channels, so there you go. We'll be tuning it, because he wants AM doing, we'll be tuning we'll probably be tuning it not with the synod meter, we'll probably tune it up on the AM. So we'll see what happens. It's some time since I've done one of these, and I have printed off the circuit in that. Now at the time, I think it's about 2010, they did the CM10 and the CM70, and the CM70 being the bigger and more expensive model. But I actually find this CM10 works better. And of course I've found this, especially in recent years with current models, that the more you pay, the more bells and whistles you get, but not necessarily any better performance at all. So that's a Maxon CM10, upside down. And you know what? I just did the parcel for that base station to go back, and I've gone and taken the pen in the other room. I've got 45 minutes, so it should be enough to do the set. What is it? Something like the 17th? I don't know. We'll probably fill that in later. Maxon CM10. I'll put the soldering iron on in case we've got to melt wax, or in case we've got to take the speaker off. So we'll run through this. It's on a cigarette lighter plug, so we'll just put our crocodile clips to that. Something we don't have on this bench is a cigarette lighter socket. I'll put it straight on at 13.8 volts because it's not a faulty set. I haven't got the foggiest how it's put onto different countries, which we're going to have to do, aren't we? Because if he wants it doing for 80 channels. So we'll put it to channel 20 and we'll find out what channel 20 actually is. Well, the good news is it transmits. I've put it to my extension speaker instead of to the test instrument speaker. Switch picture in picture on. So I'm going to start with the 3-watt scale. It's more than 3 watts. It's 3.2 watts. Oh, what channel is it really? What we're going to do I'm going to do channel 1 CEPT, channel 20 CEPT, channel 20 UK and channel 40 UK, so we can see what kind of power it's doing over the 80 channels. So I'll kind of turn this column into this one into two. So at the moment we're at 3.2 watts. I'll pop it up to channel 40. It's 3.1 watts. I'm just going to take it to channel 20 again and do the power consumption. It's 1.32. They are higher, you know, on modern sets because of having CPUs. These don't have low power. They're not. That's for 2781 stuff. This is a CE Multinorm. So I don't know whether he's got. I don't know whether he's got. CPT in this, so let's just have a look. Yes, he has. So on channel 1 of CEPT, the radio is doing 3.1 watts, and on channel 20 it's doing 3.2 watts. So I tell you what, that's spread pretty well. What I didn't want it to be is 2 watts on channel 1 and 4.5 watts on channel 40 over those 80 channels. So I'm going to go back to UK set of channels because our deviation meter is set up for that. Wallow, 2.1. Just wants to come up a little bit. We won't be doing the VCO, and let's have a look at the frequency. Switch that to that camera. 27,79098. So we'll just pop that up a little bit. It's not our frequency as such. Now, I'll tell you what we'll do. We'll go to channel 1 of the UK band, and we'll see what the sensitivity is. So I'll set the signal generator up for 27,60125. It's slightly off frequency is set, so we'll just make the signal generator slightly off frequency. That'll do. So for 12 dB synad, so I'm going to put channel 1 UK. So normally we do everything on channel 20. Let's put that on the synad meter for you. So for 12 dB we have got 1.15. For 10 dB we've got, I'm going to change scales for that one. We've got 0.85. And if it'll do 20 dB, it's 5.1. There's no meter on these, good. Squelch. Turn the squelch up to full. See where that is. Put the attenuator on. I'd like him to open at 100 microvolts. That's not doing, but it's opening at get an accurate figure. 300 microvolts. These, I think these have got an auto squelch or a preset squelch position. Yes, it's switched. So we'll set the squelch threshold on the radio. Switch the signal generator back on. Straight in. Do that again, it's not too much on the edge. Try again. That's better. So it's 0.52. ASQ is currently set to I'm not going to touch that. Right, we'll get the set opened up. I'll probably have to find some instructions from somewhere and find out to put it into a country where, at the time this was made, AM was permitted. Because in the UK at that time it wasn't. Now this radio is CE approved, so we can use it legally in AM, but by some jiggery pokery of putting it on another country. I don't like doing that. It's a bit like the Midland 78 we've got in the car. Mr. Chippy's going to have to put it onto, I think it's Spain mode, or is it EU instead of EC, something like that. It was late 2014 that the UK was allowed AM on the CEPT set of channels, and therefore radios manufactured after then, absolutely okay, but not necessarily so with earlier ones. And certainly not with anything which isn't CE at all approved. There's a misconception that people can dig illegally imported AM old clonkers out of the cupboard and use them legally. Well, they can't. Right, that's taking a lot of screws out, like you do. Yes, it is a soldered speaker. Still a small speaker. Well, there you are. It's modern sets, isn't it? I think the best thing to do is probably to set this up on CEPT channel 40. Because if possible we're going to tune it up on using AM on receive. And obviously AM is only available on CEPT band and not on the UK set of channels. So there are extra fees for when we have to do 80 channel and when we have to do AM. It's a lot more work with the test instruments in resetting. It may not look it on the video, but these are edited. So there is a difference in fees. And the performance is inferior. We may as well start by putting it on frequency. There's no distress capacitors that I can see. That's going to be our VCO, which we're not going to touch. It says June 2010, there's a date there, and it clearly says CM10. I love the footprint for a full-size capacitor there, and then it's got a tiny little surface mount one. They've got the options, haven't they, to use the big ones. Might help us if we had to ever replace one. So there we are on channel 40. It should be 27.405. So let's just check, and we'll get his on frequency. As ever, that's the wrong way. There we go. On frequency. So the other crystal there is going to be the reference crystal for the CPU. So looking at this, it's going to be L301, L302, and then they've got a one that they stretch or compress depending. Maxon are good at doing that. I'm not saying I like it, as I go over to the printer and pick off the 4 pages of the service information. So I'm just going to check on the circuit diagram that it's as straightforward as those two. So 301, yeah, that's it. Simple as that. It's going to be power control, we'll come to that. Right, let's put the other meter up on the screen. Will we be able to get more than 3.2 watts on out of the set? So we've gained 0.1 there. So there's going to be a power control on this. So I have done one of these once before. TX power is RV1. RV1. RV1 is the preset there. And that's already at full. The next thing is this. Let's just compress this coil a bit. That 3.4 is the max we're going to get there. Check that's okay. The wrap round a former, which you think is adjustable but isn't really. Placement of these coils can affect it. No, that's it, 3.4 watts. I think we'll just pop this down to channel 20, which is where we're checking. Just key up again, 3.4 watts. I'll just go down to channel 1, seeing as we can easily. But I'll do all these. It's 3.45. Let's go into UK. Channel 20 UK, 3.4. And channel 40 UK. Back to channel 20 and see what the transmit current is now. 1.282. So again, we've retuned the transmitter. We've ended up saving a bit of power there for more output, which is always nice. See if we may as well do the deviation while we're on UK channel 20. Wallow. Wallow. And deviation, I've not looked up. Is 401. Wallow. That's it. Spot on. Good, that's made a start. Right, let's go to channel. I think we're going to have to reprogram this for CPT next, to be honest. And I'm going to have to look up how to do that. So I'm going to pause the video and see if I can find an instruction book. Okay, so I managed to print off a copy of the instruction book, which we've also got on file. It does tell us how it's supposed to work. It's supposed to be 13.2 volts. It's supposed to do 4 watts. So, as it's set at the moment, it's showing 7, so it's correctly set for UK. So to use this set on AM and FM, it's going to have to be 1, isn't it? So it's Spain. We have to set the Midland 78 to ES, isn't it, for Spain, or just España? If we set it to Europe, it's going to be 1 watt on AM. If we set it to Italy, so it's 0, 1. Right, here we go. Turn the radio off. Well, that was easy. Hold and press the up down and turn the thing on. And it will blink. Now, select that with the up and down key. So we want 1, and then what? Press and hold the down key. There we go. So now we should, let's go to channel 20. So we should have 27205. Let's put the frequency counter on. See, I wouldn't have guessed that procedure without the information. So we should have 27205. It's weird, we've got absolutely nothing. Let's switch it off again, switch it back on again. So we've now got 27405 for channel 40. So we're in AM at the we're in FM at the moment. Switch to AM. No, that is FM. So that's AM. Yep. So we use the cyanide meter still, but we'll tune it up in AM. So we're on channel 40. It's actually easy to do it AM. I could just use an AF voltmeter, but we've got the cyanide meter, so we're doing that. Right, let's see what we've got. I think the IF is out on this set, and that's something else we need to address. So I'm going to start with the front end, which is going to be whatever it says there in tiny letters. L3, L4, L102. L3, 4 and 102. So we're going to start off with those. So L3, L4 and 102. 3, 4, 102. Let's see whether we can improve it. So we'll set to about 4 dB like we usually do. Three, 4, 102. Tiny little bit there. So what's the where do we go from there? We've got an FM detector, so we need to avoid that for now. Except we can quickly switch between, can't we, on this set? 104. So 104, that's going to be the FM detector. Let's switch to FM. 100 microvolts on. So we're going to look at this on the oscilloscope to maximise it. To be honest, I can't see much difference at all there. Why is that? Oh, there is. Let's put more volume on. That's peak. Just make sure that the pressure wasn't doing that. Yeah, that's peak. So I'm interested as to what 106 is. Turn the volume down. Well, it looks like 105. But seeing as there isn't a 105, it must be 106. So that's the AM detector. Let's turn the signal down. Let's put a big signal on. Small signal. It's right down. So what's L3? That's where we should have started. We did. It was that one. Well, it's 103 then. There's the door. I think it's a power supply and a CB I bought off eBay. It might just be a power supply I bought off eBay. Lost my train of thought. I was looking for 103, wasn't I? Yes, Mr. Tango. Oh yes, it's the next one in the receive. Yeah, I can see it now. Now, I've peaked those to what I think is best. Now I'm going to change tactic. Just do that again. So I'm getting AM is always different. No, we'll switch it to FM because it's different sensitivity on AM and FM. It's always less sensitive on AM. So I'll just go back to FM, switch the test set to FM, and let's just see what the cyanide reading is. So at the moment we're at 0.95 microvolts. So I'll just put that there. I'm now going to change tack, and what we're going to do is I'm going to tune it FM. So it's exactly the same, but I'm just seeing whether I get a better result by tuning it FM. Let's go over to the cyanide meter. So we've done the AM detector. Just check the FM detector a second time. Okay, let's see if we get a different result. Turn the volume up a bit. So the 12 dB, I've actually got a better result. I've now got 0.88 microvolts. So whichever was the best technique, we're going to leave it tuned as the best technique. So in this case, I was able to tune it as an FM set to a better accuracy than I could as an AM set. So there we are. So all this front end is going to be the same whether you're AM or FM. The difference is between the AM detector and the FM detector. So there you go. It's not like two receivers. So that's improved that. So I think we're done on there. So let's go over to AM modulation. Now I'm going to have to retune the test set. This is why there's an extra fee. It's a lot of faff. 1, 2, 3. Where are we? Main meter. That's it. So we're in AM mode. Let's look at percentage modulation. So full scale deflection is 90%. Power supply is shutting down because this radio wants more current than we've got. So I'm going to have to change the current limit on the power supply. So this bench power supply is what? 3 amp. We normally have it set to about 1.6 and the radio was drawing 1.32. So now we're in AM, it draws more current because you're modulating it. So you've got audio 4 watts and you've got the transmit carrier 4 watts. So the thing always draws more current in AM. So how do we do this? Because I don't normally have to alter it. Current. See whether 2.9 is enough. It is. We've actually got 4.6 watts as it's now called, because we let the transmitter 4.6, 3.6 watts as we let it cool down. So am I in AM or FM? I haven't got the foggiest till I listen to it. And I've had to unplug the speaker because it's interfering when I go into AM mode. So I'll put it on the external speaker instead of the test instrument speaker. So that's FM. So that's AM. So here goes. Wallow, wallow. So it's not quite 90%. The meter doesn't go above 90% because you wouldn't normally ever have a transmitter doing more than 90% modulation. But it seems to be something left over. It's 100%. You don't do 100%. You end up with what we call squedging, and that causes mega interference, doesn't it? When I was doing business radios at Nottingham Radio, there was a lot of AM VHF schemes on taxi firms, and so we talk about VHF high band, 170 megs transmit, 166 receive, split frequency, and most of the radios were 10 watts output. I've said before though, a lot of them have 60 watt PAs to do that for reliability. And I said to Mr. Smith, the owner, I says, what's the pass mark on percentage of modulation? He says 45% is the pass mark. So, this goes to show when you're in business radio, anything between 45 and 90% was correct. So, oh, where's AM mod? It's all right doing this, but I haven't looked it up. RV201. So it's this one. Wallow. That's gone over the top. Wallow. That's about 91%. It's just gone to full scale deflection. I don't have any columns on here for so it was 85%. It's now 91%. That's now 2.2 to 2.5. The frequency is now 27,79125. Good. So hopefully we've not affected FM deviation, which I'm going to check. So back to FM on the test set. Wallow. That's possibly peaking at 2.6. Right, that's that done. So as far as I'm concerned, it's Squelch next. So we're not going to touch the ASQ with the preset one. We're going to just adjust RV2, which is the normal squelch. So turn the squelch to full. I've now got 100 microvolts on the attenuator, 100 and 0, and RV2 until it opens. RV2 is that one. Okay, it never opens. That's the end stop. So that's as sensitive as it goes. So let's see where that is. It's 250 microvolts, so at least it does open. There's no rule about this, but I like it to open at 100 microvolts on the tightest, so it's now 250 microvolts. So we have brought that down from 300. So now we'll check it on the sensitive end. So we'll turn the signal generator to standby at 0.3 of a microvolt. We've switched it, as I say, to standby. Let's turn the squelch on the radio. Set threshold. Switch the signal generator back on. I've actually got 2.6 microvolts this time. I'm going to try harder at setting the squelch. Let's try again. Again, I've set it to fine. It's 1.6 microvolts. It's a bit, where you have that is pretty, the squelch control is pretty difficult to set exactly where you want it. Let's just check where the ASQ setting is. Last time it was 12.5 microvolts. It shouldn't have altered. It's actually 15. I do want to lower that. Let's adjust that then. So the ASQ preset is RV3. I've overdone it. It's just over 10. Let's get a more accurate figure. Just strengthen that up a bit. And again. Once again. No, that's too strong now. It's about 11 there. Yeah, 10 to 11, somewhere around there. Let's give it, let's say it's 10.5. Right, so we're on channel. I did the sensitive on UK channel 1, so we'll go back to that before doing the sensitivity. Yeah, that's the thing to do. I just said to you, sets are usually less sensitive on AM than they are FM. I wonder if it says that here. Yeah, so it says 0.5 microvolts for 20 dB synad in FM mode. Doesn't say AM mode. Sneaky. Right, I think we've covered everything. So RV3 was ASQ, RV2 was Squelch, RV201 was AM modulation, deviation was 401. That's a piece of parcel tape stuck to my thumb. That is the FM detector. That is the AM detector. And then these are receive. Good. And obviously that's frequency. So I'll leave that like that. I'm just going to zoom out slightly so people can take a screenshot of that. Right, let's turn it back into a set with UK channels. So it was switcher set off, switcher set on, holding the up key. So it's 7, and then press and hold down. And then we found we had to switch it off and switch it back on again. So I want channel 1. So what band am I on? I'll just tell you by going on the frequency counter. 2760125. We're on UK. It just needs bringing up again. So 27791260125 on the signal generator. Right. We better plug the test instrument in. So we're on frequency. Let's see what we've now got. So on channel 1, no, what to do? Oh, doing it channel 1, aren't I? Yeah. I thought, why aren't I doing it channel 20? On channel 1 for 12 dB, we're looking at 0.85 microvolts. For 12 dB, sorry, for 10 dB, we're looking at 0.72 microvolts. And for 20, if it will do it, it will. It is 2.4. So considerable improvement there. Now, that's the centre of the band. Yeah, I think that's going to make quite a difference. We've not brought the power up much, but we have brought the power up. Let's have a final check on that. Transmit power. From cold is 3.6 watts. So this is when it was warm. It's 3.6 when cold. Bits of noise on that volume control. I'll spray that later when I get a service I'll off Mr. Chippy's bench. Serial number 12070000771. So after lunch I'll put that together. Right, back onto this. It's put together. It's on the aerial. How do we know whether it's on CEPT or UK? Right, let's go to channel 20. Testing 1 2 1 2. So as it's come on, it's on UK. So if I press the AM FM button, it now should go between CEPT and UK. So when it's showing a decimal point, it's on CPT. So I shouldn't be able to hear my handout anymore. Testing 1 2. No. Good. And then, as I say, if you wanted it to go into AM, it would have to be CPT only, go to country code 1, and then... So it's a bit of a faff because these were manufactured before 2014 when the rules changed. So, we're not interested in CPT, but when we do the on-the-air test, it's been requested that we do an AM, FM, and CPT comparison, so we're going to. So we're going to run it as normal on channel 31. Remember, this set's been optimised for the centre of the 80 channels. So channel 31 is going to be about as bad as it gets, isn't it? Away from that centre point. We're then going to switch to CPT and continue the test conversation at the 5 mile point on CPT FM, and then we're going to switch to AM, which will be a faff for this. It'll be a faff for the one in Mr. Chippy's car, because that's that Midland 78 is a similar thing. You've got to reprogram the country code. So that's what we're going to do. Then we'll switch it back to UK FM and finish the test. So it's going to be comprehensive to do that. Now, sensitivity is usually less on AM, so I don't expect it to work as well. But theoretically, AM and FM are identical range. They just work differently. Right, let's see if anybody's on this channel. 1 Anna Roger. Oh, I'm on CPT, aren't I? That's better. 1 Anna Roger. $19 Roger. No. Okay. So we're doing on the air test, I say, later on. But there will be an AM test portion as requested. We're doing it as a one-off, not a regular. It's of no interest to me, but somebody has requested. We've done it before. We did it on a CRTS Mini, but we're going to do it a bit more detailed this time. So thanks for watching. Maxon CM10 from 2010.